Hey, welcome back, everybody. Once
Hello.
again, we've got me, Kevin, and there you hear Zach. Hey,
Hello,
Zach.
everyone. Hello. Welcome back.
Zach and I have both recently gone back to our respective universities for the new school year, but we thought it might be a great idea now that we're back in school, and we know a lot of you are going back in school, to talk about one of our favorite Wolfram products for school-related things, which is Wolfram Alpha.
True
This
favorite.
is Yeah,
Go ahead.
definitely a favorite. It's online, so it's easy. You just go to wolframalpha.com. There's a free version that gets you like pretty much everything you need. You can really ask it any question, and it'll give you any answer to it without even having an account. So it's a really helpful website for a lot of things, not only school related. That's what we'll talk about today, but for everything. As you can see on the screen right now, there's a ton of topics that are available. So we wanted to talk about what we use it for in school. One of the biggest things that I know Zach and I are both studying physics related topics. So we use the math input a lot, super helpful. And yeah, with that, just take it away, Zach.
Yeah, so we're here today to talk about some of the new features. The big thing that we want to talk about is the new math input. It's pretty interesting. Normally, if I wanted to type out a function, I type out like log of x, and I do that, or maybe log of x over 2. So it can get a little confusing at times. With the introduction of the math input, it actually formats it like you would write a math problem. Um, you can use math symbology too. So I'll get into that as we start to talk about it a little more. But just to start, simple stuff, you can type 4 squared and you're gonna get 4 squared.
So that
You
was
know,
just a caret symbol, right? Like
yeah,
shift
this is the
six.
caret. The same way you would normally do it programmatically, it just formats it for you so it looks nice. And it'll probably match whatever you're working on if you're doing this from like a scientific paper, you're just looking at something. Um, hopefully it can make things readable and a little faster so you keep track of things, especially when you get more complicated functions and things like that. Obviously, if I wanted to divide this, I'd hit the slash to divide. Maybe I wanted to multiply it by 2. Then it does it. Boom. Look at that. Very nice.
Yeah, so it's even just kind of like a calculator, but better, right?
It is essentially Wolfram Alpha calculator, right? It does a lot more, but but it starts as a calculator. It's a favorite of a lot of students because it's very easy to use, but there's a lot of
Right.
other things it can do, and we'll start to talk about some of those as we get in there. One thing I did talk about was we can do certain calculus operations. So we could take the derivative. Uh, I cannot spell, I'm sorry. Fortunately, it'll spell for me, of
Yeah.
2x, derivative like that. I can write it like that, or I can write it like this, and we actually have the derivative symbols. So we have derivative of 2x, we'll get that. We also have partial derivative. I don't know if no one knows what a partial derivative is. It means we just take derivative of that variable and nothing else. So if I do 2xy and I do the partial derivative, it leaves 2y. So just an interesting thing you can do. Thank you, Icy. I appreciate it. We're excited to be back. We were pretty busy. Both of us have returned to school, so
Yeah. And
hopefully we'll be able to
definitely,
continue these.
yeah, we want to keep continuing this. And for those of you who are watching, feel free to keep those comments coming in the chat. If you ever
Oh,
have a question, want us to try something out, we'll give it a shot. So
oh
just let
yeah,
us know.
that's a big thing. If you have something you want us to try, we'll try it. Just like we did in live coding, if there's something you want us to try, we will certainly try to enter it. Maybe it won't work, but we'll give it a try. Um, Other things you can do with this pretty simply, if there's popular things that you can use that you would expect, like your roots, your sums, your limits. The nice thing that I think a lot of people will appreciate is the introduction of formatted matrices. I know, and vectors. I know for a lot of people, it was very confusing to type like, normally I'll show what we normally would type. It would be like it'd be a curly bracket, then a curly bracket, then you would type, 3 numbers, and then you put another curly bracket, that's 1 row, and then you'd have another curly bracket with another 3 numbers,
Yeah, so it's kind of like
and
nested lists, but it
it'd
might
be a
not be
little
intuitive.
confusing. You might even mess things up, and you might even confuse it. Now
Mhm.
we have the math input that allows us to just turn this into a, what's it called? A really well formatted matrix. So I can just enter it like tab it 3 by 3 and I go 1 and I hit tab and it goes to the next one. It goes next one, it goes next one, goes next one, goes next one. And I'm only hitting the tab key. So hopefully it'll make entering these things a lot faster to keep track of.
Yes, this is super helpful for any sort of linear algebra
Oh,
class.
definitely.
Yeah,
It's always difficult to keep track of things.
especially if you hit this calculation. So here you've just entered the matrix, right? But look at all the results that we get.
Mhm.
Like now we know it's trace, determinant, even its inverse.
So yeah, I think some of these are really cool. I know for this diagonalization stuff,
That's tough.
I took a quantum mechanics course last fall, and we did a live diagonalization.
Yeah,
And my professor always said, he said, do it once, know how to do it, but don't do it all the time because it's very difficult and it's very arduous to do this kind of calculation. So, it's just so hopefully this can kind of, speed things along, especially if you're just trying to practice stuff. We'll even talk about that later. We're going to talk about some things you can use Wolfram Alpha for practice and things like that. So
yeah.
hopefully you can take advantage of that when studying.
Especially with these types of calculations, like that diagonalization or inverse of a matrix, there's a ton of steps. And if you mess up one of those steps, you get the wrong answer at the end. So just being able to check your answer here against what Wolfram Alpha knows is the answer can tell you kind of where you went wrong. And in addition, not just knowing the final answer, but you see, Zach, you want
Oh
to
yeah.
click on step by step. There's actually, we're able to show every single step in the Gaussian elimination to invert this matrix, which is kind of crazy.
Yeah, we can do the inverse formula instead, which is just confusing. I don't know why you well, I mean it's not confusing. It's just a lot. Just a lot. But
Yeah, yeah,
what are they say? Yeah, and the nice thing is it's gonna show you intermediate steps. So maybe, you don't know how to do a problem or you want to like try to understand the process. You can use this with another example, or maybe an example from your lecture if your professor didn't really go into details on it. This can help you kind of break things down and give you a deeper understanding of how to find the inverse, not just finding the inverse of what you want. Um,
yeah.
and it's
And this step by step there, we get it where we have Wolfram Alpha Pro, as you see. So definitely check and see if your school offers that. If they do, that's a really good way to get a lot of helpful information, like these step by step sorts of formulas can be really helpful. It looks like someone's wondering what teachers think of using algebraic manipulation with a computer. I would say in my experience, if you're using it to check your answers or to practice and just make sure that you're doing things right, teachers really appreciate that, because it if you're doing it that way, it shows that you're more serious about it, sort of. You want to learn. And I think that teachers really appreciate that in my experience. Is that what you've
It
seen, Zach?
is. Yeah, actually, I'll flex on my experience. I'm actually a trained high school teacher. I've taught high school physics and high school like honors algebra 2 and some calculus. And I gotta say, from my perspective, you know, you can use this in many ways. And really and truly, you can learn from this. You can really practice with it. Or you can try to use it to just cut out all the hard work. But at the end of the day, you're the only one losing out. You're not gaining, the teacher isn't losing out. It's the student that loses out by doing things like that. So, honestly, it's not really even going to be that helpful for it either. I think what really is helpful is the step-by-step solutions and what we'll talk about at the end, which is the quiz generator and the problem generator, which I think is going to be super helpful because I know as a math student, I'm really bad at math. I picked physics. It's very math heavy, but I'm like not naturally gifted at math. So for me, I have to practice math a lot. Um, and in the future, in your professional career, you know, if you're an engineer or a physicist or someone doing, higher level science, I know that I forget how to do certain math operations that you would think are just like basic.
Oh
And,
yeah.
it's nice to be able to just turn around and be like, okay, I'm just gonna find the conjugate of this matrices because I have other work to do and like I have a more important things to do right now. So like, it can be used as a tool to, cut out the tedious middleman algebra to maybe focus on the more important topics of it.
Or
And
it can even, I've used it to jog my memory sometimes. Like we just saw there, taking the inverse, and when you go to step by step, it tells you, oh, the first step is to do Gaussian elimination, which kind of brings me back to linear algebra
yeah,
and makes me say, oh yeah, right. I remember doing that. Yeah.
yeah, it's always up to the student, but I see this as a big positive, and I actually use this a lot to study for my quantum mechanics courses because they were able to give me examples of a lot of linear algebra that's used to make propagators that we use for building wave functions. So I should use that a lot to practice working with propagators. So it actually is a big help. Um, and in the words of my quantum professor, he says, you can look for the answers, but you probably won't find them because he usually makes them up. So
Right.
if you have a professor like that, nothing's going to help. Um,
Except yourself.
yeah, except learning it.
Yeah.
What's it called? We will, well, I guess we'll just keep going along. So I guess I did conjugate, which is just the complex conjugate. I just thought I'd show this because this is something I use for physics a lot, and Hermitian space and things like that. Find if you can ask if a matrices is Hermitian, and it's going to be false because it has what's it called? It has imaginary parts and things like that.
Yeah.
You can also do stuff like this. You can add two matrices together. So I can just add them like this and like um you know and we don't even need to think about it.
Right. Or matrix multiplication.
Take
That's always can be tough with some big matrices, but
take the
there it
product.
is. Yeah.
Things like that. It's all there and it's all really easy. And I think what's important too is to think that these are all tools that are available in Wolfram Desktop. So if you look at this and you're like, gosh, I wish I could do that in Wolfram Desktop, you can.
You can.
And you can even take advantage of Wolfram Alpha's input in your notebook. We'll talk a little bit more about that later in the stream.
Yeah, and what's especially helpful with having Wolfram Alpha though is you might get answers that you didn't even know you were asking the question for. Like here, Zach multiplied these two matrices, but he also found the resulting trace of the answer. So it's kind of taking you that next step without having to do a lot more typing or computation yourself.
Cool. I didn't know it could take a Kronecker product. Sorry guys, I'm getting distracted. The next thing I'm going to talk about is our integration tools and like just visualizing an integral because you look at an integral, it get a little complicated at times. Where is it?
Yeah, so if you're doing
Oh, right
calculus
there.
or trying to remember back to your calculus class, this
So
this is it.
we have an integral. We can make an integral if we wanted to, and we can make something easy. We'll do I can actually enter the symbol for pi, so I'm actually going to do that pi. And we're gonna pick like a good function. Hopefully this won't be a number. Oh, it's 0. Very
Yeah.
nice. But you can enter pi if you wanted to, and you can make a definite integral. Um, Pretty easy stuff. You know, there's a lot of times when you're working with Fourier series, or if you do Laplace transforms, where you need to take the integral, you need to take an integral of, a transform and then take it back to your x coordinate. And this can help speed things up a little bit. Also can help jog your memory because I was supposed to memorize the integrals of sine and cosine from 0 to 2 pi, and I can't remember them for the life of me. So it's good to have a place I can refer back really quickly.
Yeah, especially
Um,
if you're doing something more complicated too, like oh you've got an answer that's sine times tangent times,
mhm.
divided by whatever, and you just you can't really think about, well, how would I even start to attack this problem? You can put it in, hit the step by step, see what that first step is, and say, okay, I'm a little bit closer to my answer. Let me try it from here too.
Next thing I want to talk about a little bit too that's really cool is we can actually work with indefinite integrals. We can actually have an integral from 0 to infinity of log of x. This isn't gonna converge very obviously. But we can have these kinds of integrals which are pretty nice. So we could pick something like 1 over x that converges. Oh, it doesn't converge. I'm
Not
sorry,
when
guys.
the lower bound 0.
I don't know math. I'm sorry, guys. There we go. But
Try x squared.
anyway, guys, I'm
That's
sorry. I don't know
fine.
math. We can take we can take lots of indefinite integrals and just like plug them in. Pretty easy stuff. We can also, if we wanted to not, solve the integral, we can just take the integral itself. I gotta go back to it. So we could just take an integral without solving the function. So we could just integrate like x squared plus what's it called, x
Right. So
squared.
if you don't have bounds, you're trying to get a function out of this, basically.
Yeah, we can just take an integrand and integrate it and have an analytical solution instead of a solve solution.
And then it also plots the answer for you. So it's kind of taking you that next step.
It's very nice. We can see alternate forms. If we want to do a definite integral if we want to do a definite integral, we can do that. It's pretty helpful. It's all around, like, it's going to give you a lot of information maybe you didn't consider about the function. We can do a lot of things with it, like anything, the stars the limit. So if you have something you want to try, we can certainly try it. And just so you can understand like how much of an improvement this is, normally this is what I would have to do. This is what I have to type in if I was going to do in natural language, or I would have to do integrate x squared plus 4x cubed, and it would come up with the same answer. But if I do it in math cubes, it looks like that. And even if you don't want to type those symbols, I will answer that in a second, Bob. I will point this out too. If you don't want to type in symbols or you just want to look at it, you can just type derivative or third derivative. If you want to take the derivative 3 times, you can still do that. Oh, I'm sorry, guys. I also can't spell. Sorry about that. You could type in third derivative, and it'll just do the third derivative for you, just like that. What's it called? Yeah, so it's pretty cool stuff. Obviously, the motivation for analysis is to make it just easier to use. I'll touch on another thing we can do, which is work with summations. I don't know if Kevin wants to chime in on this.
Yeah, sums. I mean, this is something that you're going to do a lot if you're in some sort of calculus class. Sums kind of, might lead up to integration, because integration is just adding a bunch of things together in a sense. Let's see. So what do we have here? Wow, look at that. All those numbers.
Yes, we've made a sum, but we could do things. We could
How about do the sum of, try 1 over x squared from 1 to infinity.
1 over x squared. Okay.
Yeah.
You mean x
or
I
I
squared?
squared, if you're using I, yeah.
To infinity. And I could just type in infinity too.
Yeah.
I don't actually need to. I don't actually need to use a symbol. I don't want to, because it'll solve that for us.
And look at that, pi squared over 6. That's the answer.
There you go. I'm told that is a very famous math theory. So, very cool math stuff.
Cool math. Oh yeah.
I guess, okay, so we had a question from chat, which is, if we type this in, why is it false?
So this question here is comparing these two. It's saying, is 1 to the x the same as 2? And the answer is no. But if you're looking to solve an equation, then it's as easy as just putting the word solve in there. So if you just say solve 1 to the x equals 2.
So there you go. It's true now. But now if I put, you're okay, solve, it should solve for x.
And there's no solution.
There you go. So it would always look for a solution. So this is just, so when you have the equal sign, it's just going to say, is it equal? And you're going to say, no, they're not equal. And then if you put solve, it's going to attempt to solve it. Now, there's no solution. I really can't control that. You can take that up with the guys at the math team or who make mathematics.
Yeah, so think of it more as you're kind of telling the computer what to do. You're telling it to solve an equation, or you're telling it to integrate a function. And it will do its best to do what you ask, pretty much.
Mm-hmm. Let me think. What else do I have to go over? Well, we talked about some linear algebra stuff. Let's talk about just some normal information lookup. Something that Kevin has who seems to like a lot is porcupines. So
Oh
we
yeah.
can actually look up information about porcupines.
So now we're actually entering kind of the Wolfram computational world. There's a ton of data about any topic, and you can do computation with that data, of course.
Yeah, we could link the porcupine
Yeah,
divided by weight of
time.
porcupine. I wonder if this will work. I wonder if it's gonna be confused. Ooh, it
Oh,
was confused.
close. Try
I got
just
it.
porcupine length divided by porcupine weight.
Yeah, this is probably how you do it. Look at that. Wow, this number, I'm sure, look how meaningful
There we
this
go.
number is.
Inches per pound. And
That's
so if you wanted to, you could try to compare this number for different animals, see which has a higher length to mass ratio.
yeah. It's pretty cool stuff. If you give it, and we have lots of interesting version. We have a picture. We can go to the source of the picture if we wanted to. It comes from, oh, I guess the source doesn't exist. Goodbye, source. We have its body temperature, length, tail length,
The
lifespan.
taxonomy data is really cool too. Down here, this you can see, so it's kingdom Animalia and the rest. If you're taking a biology class, hopefully you know what all those words are.
And if we go to one of the if we go to one of the, what is this, a class? This is a class? No, this is an
Yeah,
order.
you're looking at the order of rodents, I think.
Yes, you can look at
Yeah.
this and you're like, oh, look, here's the order. Now, I believe you can also lifespan of all in order. Pretty sure you can do this and it'll display the lifespans of every creature we have.
Oh, cool.
Oh, it just gives a general thing. This is
Yeah,
how
so it's
long
it's a range. Live
we have.
between 2 and 30 years. That's cool.
We have a human corresponding value. Um, one rodent year is approximately, what is it, like,
Hmm.
I don't know, some amount. We can look at the maximum recorded lifespan of a rodent, which was 42. I don't know.
Wow, 42 months.
It's an old rodent. He was 120. But yeah, you can look up things like that. So if we wanted to know, I guess we want to look at, what else do we want to look up?
And I also might just mention that when we're normally doing things on our live streams and we're writing out code, it sort of has to be written a certain way. You need to use a curly brace here instead of a square brace, stuff like that. When we were querying Wolfram Alpha, there's a bunch of different ways that you can ask the same question because it's just trying to give you the answer to the question that you asked. So like here, turkey's in Turkey. You could say turkey's in the country Turkey. You could say turkey's turkey content, maybe something like that. Whatever you think the question is, it'll try to find the answer.
Top 10 countries by livestock population. Oh, this is cool. Okay, so Brazil has the estimated most cattle. Who has
Wow.
the most pigs? China. Actually, I want to see if I can look this up. Number of pigs in Denmark. This is a little fun fact I learned when I was visiting. All right.
What's that? Oh, there's
There are. I'm really sure there's more pigs than people in Denmark. Yeah. There's more. There's a couple more.
2.17
Yeah. So
pigs per capita.
yeah, pigs per person. So there you go.
That's cool.
So there's a fun fact for you. There's more pigs than people than in Denmark. So yeah, so I guess it's really important too is we can query information and we can then look it up and we can pull that information up.
And then that can kind of give you a jumping board for an exploration that you might want to do in the Wolfram language, like we've done in past live streams. So if you saw that and said, oh, there's more than 2 pigs per person, then maybe you want to compare it to other countries, and you could probably create some sort of histogram in the Wolfram language if you were interested.
Um, we'll talk a little bit. I just want to jump in a little bit about chemistry because chemistry is like a good go-between like just looking things up in biology and mathematics. We can look up chemicals and compounds, and we should be able to get a drawing, a structure diagram. We can get a Lewis structure. I don't know what a Lewis structure is, I'm gonna be honest with you guys, but we can get a lot of interesting information maybe you didn't know. If you can name a reaction, Kevin, I could type it in and it'll actually balance it.
Ooh,
I'm gonna try to remember if I remember what it is.
let's see. What's a good chemical reaction we could use?
I'm just trying to. I think I had oxidation on my mind like a couple weeks ago.
Uh-huh, you got one?
I don't remember. It's like FeO3 plus H. I don't remember. Someone can correct me.
Ooh, it's a reaction.
Well, I mean, I don't know if it's an actual reaction that's that works, but but it's worth noting that it actually does the wherewithal to balance it. It's noticed that it actually balances hydrogen as a bonded pair, not
Mhm.
just a single hydrogen like I entered. So, this is something to do. You can look at the equilibrium of a reaction. This is oxidation. This is yeah, it's an oxidation. There'll be an equilibrium. And you can look at all the information for it. So it's, you can look at its molar mass, things like that. It's hydrogen odorless, things, interesting stuff like that. I don't know why there isn't anything for iron. Maybe it's because I'm looking at iron 3, not just iron. But yeah, we can like, if you're looking up reactions, you're like, oh, how does this reaction work? Okay, I'm gonna pull that up.
Yeah,
And
you
we
could
kind
do
of get
the
this stuff.
photosynthesis.
Can we get the
If you're learning about photosynthesis at all, so that's when you get carbon
can I look that
dioxide.
up?
Oh yeah, just try photosynthesis. Let's see.
I don't know. It might give us just a definition.
Oh, okay,
Um,
yes, this is kind of about the word.
okay, I'll look it up. I'll see what we can find.
There is the option up top. It says use it as a. Okay.
Oh, well,
Mm,
um,
this
hmm.
is just about general chemistry stuff.
Yeah, well, okay. There's still some cool stuff though.
Yeah.
We can see this. So you can look at chemical reactions like combustion, which is
Oh,
kind of
cool.
cool. You can compare all of the funny names for things and what their chemical meanings are. As I understand in chemistry, chemicals, that's the balance equation. I'm glad someone, oh, okay. Someone just sent us an equation that's balanced. I appreciate that. So we can look at things like that. I mean, if you're trying to like practice and like look up information, I know there's a lot of information recall in chemistry, especially organic chemistry. This can help you kind of recall that information in a quick and easy way that kind of lends itself to being like, oh, I kind of know what it is. Like I know what this is, but I don't really remember much. So I just want to look up owl structure. So I want to look it up and like I just remember it. I need to study it. Okay, there it is. I found it. Now I can put that in my notes and on a flashcard or something, or I can even download it and I can make it a flashcard for me. Are people just sending us balanced chemical equations? This is exciting.
Yeah, try putting this one in. C3H8.
Yeah,
Yeah.
I got it.
So this is when it's balanced, but if you take away those coefficients, the
Yeah,
five
if we take
and the
away
three.
all these, it'll still balance it for us. It'll do that.
Yeah,
Now
so if you just remember that propane combines with oxygen to yield carbon dioxide and water, which makes sense. So we're combusting propane.
obvious. I mean, very obvious. Good detail.
But now you know how much oxygen it takes to actually combust that one propane molecule.
Yeah, I mean, we can cool up interesting like Gibbs free energy and things like that. and entropy of the reaction, which is pretty cool. I think that's pretty exciting. Scott, is there anything else that you want to talk about chemistry, or anything else anybody wants to chime in about chemistry? Because we're about to talk about physics, and we're probably going to talk about that for a little while.
Yeah, physics is better. Well,
I mean, it's a topic we know, so. But feel free to chime in the chat if you're interested. We're gonna hop over. I'm gonna hop over to the physics section, and I guess we'll talk about the first one, which is kind of which I think which Kevin pointed out to me earlier, which is like we can just look up a system. What system we want to look up?
just a pendulum.
Pendulum. And we want to look up the Lagrangian, or
I just type pendulum. Let's see. Pendulum
I wonder if
physical
we get
system.
all.
Maybe.
Yeah.
Yeah.
I bet. Okay.
Okay.
All right.
Cool. There.
So we can do calculate period and stuff, but we can also.
Cool.
I'm
See the
pretty
whole
sure we can
system.
also, yes.
1
So
degree of
we
freedom.
this is all like classical mechanics stuff. If you didn't know, this is action. So this refers to the principle of least action.
Mhm.
This is its Lagrangian. This is its equations of motion. You probably derived the equations of motion in your high school chemistry class, or I'm not chemistry, physics class, and you probably measured it out with trigonometry, but you can also derive them using Lagrangian mechanics.
Yep.
And then they have the Hamiltonian of it. You can get Hamiltonian's equations of motion. You can get its canonical momenta. And then if you really want to, you want to imply that your pendulum is a quantum harmonic oscillator. You can make the time dependent and the time independent. I would recommend trying to solve the time independent, because the time dependent is very it's very intensive. And you can also look at the variables and their physical quantities associated with them.
Yeah, that's important. For someone pretty new to physics, you're not going to look at that L and say, oh, that must be length of the string. So having this
Yep.
little table here is pretty helpful. Yeah.
It's also really good to understand the domains of stuff. Your angle, your plane angle, which is important, only goes from pi to negative pi, which is a straight line. So that's your pi to negative pi. And you get a little schematic too that shows how it works.
Yeah, look, that's pretty neat.
And if you want to look at, if you want to
Galileo, some
you
history. Yeah.
yeah, so you got lots of stuff like that. What we'll do is I will hop to a different system, maybe a coupled pendulum. This
No
coupled
way.
pendulum is the thing that goes on the first exam in physical mechanics or classical mechanics for every class if you ever take it. It's always to derive the equations of motion of a coupled pendulum, because it sounds really easy at first. And I'll go to the diagram first. It sounds really easy to do this, but when it's coupled with a spring between them, it's much more difficult. It creates a lot more intricate things. And now it depends on both angles. Your spring is resisting motion. So, there's a lot more complication. You can see the Lagrangian for this is a lot more complicated.
A lot more. Yeah.
Yeah. So, give you the summary. We have one Lagrangian for one pendulum, the Lagrange for the other one. And then we have the spring constant, or the dissipated force of the spring constant. So pretty cool, but it's cool that you can look that up and kind of take a look at stuff like that.
Yeah, it's almost like having a textbook that you can search and compute from.
We can look at the moment of inertia, which
Yeah.
is important for calculating physics of large bodies and things like that.
Right. This plays into how physical objects will rotate.
Yes, and we are referring to as physical quantity, which we don't. We want to see the formula. So we get a definition, which is kind of nice. It's kind of nice to get a spoken definition of it. Like, where's the formula?
That was
There we
pretty
go.
close. You had
There we go. But you see there we can look at like 3 different ways of observing this, like what we want from it. Right now we are looking now at the function for moment of inertia for a point mass.
Yeah, let's try like a physical object like a cone. Can we get the moment of inertia for that?
Of a cone.
So in this case, it's probably, yeah, it gives us a matrix. So this is
A tensor.
the
Very
whole
exciting.
tensor for the moment of inertia.
Yes.
And along its diagonal, that's the moments of inertia around the 3 principal axes.
If you've taken like an undergraduate physics class or you're in like a lower level physics class, you probably are aware of the algebraic description of it. Because that's a lot easier because it just depends on the line element and things like that. As you get higher, you want to actually make tensors. And because at higher dimensions too, and even larger places, you see
Yeah, because you
tensors
might be
more helpful.
rotating not just around its center, but around just,
Hmm.
any direction. And
Yes.
it gets a little complicated.
And that tensor can, account for that. So it's very cool. We can look at a disk. Disk is really easy. This is a tensor. It's just that it only matters for the diagonal elements of the tensor, nothing else. So it's much easier, but you can see that. See, product makes sense. The polar moment is the only special one. It's over 2. So that's pretty cool.
Hmm.
So yeah, it's like you can pull up this information, if you're trying to recall or make a formula sheet or something like that, you can kind of start pulling up this information. One thing I like it for is when there's really complicated equations. One of them that I had to do a lot in my thermo class was entropy of a monatomic ideal gas. It's a kind of complicated equation with a lot of variables to derive. And it's nice that you can just pull up that equation. I don't like to use the calculator. I have like a TI 30 calculator. So I don't use this. I just want to look at the function to make sure that I wrote the function down when I'm checking my work.
Right.
That's my big thing is like I just need to check to make sure I wrote the function down because I always write the function down wrong.
Or if you're
Um,
even trying to use that function, you might be plugging in values to it in a Wolfram desktop notebook, and now you can kind of copy that function right from here and
mhm.
use it right away.
Yeah, of course, in a Wolfram Alpha notebook, you can actually pull up these like resulting cells into your notebooks with the what is it, the natural language input?
Hmm.
Yes, so the natural
Yeah,
language
yeah.
input, it's control equals, or you just say control, yeah, control equals on a cell and it'll open the natural language input. You need an internet connection because it's going to contact Wolfram Alpha servers and pull that information from it. But it's pretty nice because if you're not sure exactly what you need, but you want to pull that out of Wolfram Alpha without or out of through into your notebook without like typing it programmatically, you can just look it up and like, look it up. Lots of other cool stuff. Um, yeah. Is there anything else that yeah, any questions that anyone could have or anything that like you want to bring up, Kevin?
How about some particle physics? I know
Uh,
you probably know more than I, but I think I can do a lot of that stuff, right?
yes, we can do a lot of like recall of particle physics data. So we can look at, I guess that's pretty crazy. Is you just can't see it. That's sad. Okay, anyway, well, I mean, I know the standard model. I study particle physics. I do research in particle physics. So we can look up, say, the heaviest subatomic particle.
Yeah,
Um,
so this is something that kind of requires computation. And if you go to, say, Google and type this in, you're just getting what someone wrote was the heaviest subatomic particle. It's not actually calculating, comparing the different
I
particles.
can't actually pull it up. We'll just look up the heaviest
Do a
quark
heaviest quark? Yeah.
because I know the heaviest quark. But if you didn't know, it's the top. Its
There,
mass is
top quark.
173 GeV over c squared. That is approximately like it's
Try
like
convert
nine.
that
It's like
to
I guess we can
kilograms.
convert it. Yeah, to
Do a
kilograms.
top quark mass convert to, yeah,
It's going to be very small. I used to know it off the top of my head, but um, for the most part, it's three. There it is, 3.8
tiny.
times 10 to the negative 25th. It's small enough that it's relativistic. Um, we use in physics or in particle physics, you'll always notice that we use GeV over c squared. And the reason that is because of the fact that energy and mass are just closely related at relativistic speeds. So it's easier to just record them as energy. And if we want to talk about their mass, we might use proton masses because, it's an easier unit to work with. You can get all the interesting stuff like spin parity, electric charge, your isospin, strangeness, its hypercharge, and stuff like that. And you can even look comparisons. This bar on it means that it's the anti-quark. And this is the top quark, this is the bottom quark, and this is the charm quark. You can look up other things. You can look up, you know, the Higgs boson, a very exciting boson that everyone talks about. You can, you know, you have, Michael, I don't know. Kevin, would you mind looking in it? Would you mind
Yeah.
looking in that?
So a question was about whether we could count the number of atoms in a protein based off its amino acid sequence. Let
Well,
me see.
I'm
I,
gonna like, I actually, I don't know. I'm not a chemist. That sounds very cool. There's been, I will say, uh, SL8RZ. I don't want to butcher your name. The Wolfram Alpha team has actually been working a lot on their chemistry tools. So we talked about it a little bit earlier. I can't go into all the details because I'm not a chemist, so I wouldn't know exactly what you need. But that is something that the team is working on right now. Although keep it in mind, if you search something and nothing comes up, click it, be like, hey, I want this. You know, that would be really cool to have. Type in all right, I will type that in. I don't know if that means anything, and I hope, oh, it is a protein. So I only want a protein. I have a reference sequence. Is that what we're looking for? I I have a
uh,
I have a lot of stuff. Amino. Boop. Oh, I guess this is it.
wow.
I hope it's it. I hope this is what you were looking for, Mike. What's it called? I guess this is pretty cool. I didn't know you could pull this information up, so that's pretty exciting. What's it called? Inorganic chemistry. Someone asked, is close enough? Well, I appreciate that. It is worth noting, Michael, that if you put this in your natural language input, you can actually pull out this resulting data as computational data. So this will come out as a list. It should come out as a list that you can use in Wolfram to just for whatever computations you're doing. Can I open a notebook and do it right now?
Yeah, sure, give it a shot.
I always mess it up. I'll do it later, or
Yeah.
I might do it if we talk about other stuff. Um, is there a question that you have in organic chemistry? Because we can hop over to the chemistry tab and we can kind of look in there. Because it all depends on what you want. The closest thing I know of with chemistry is I did a lot of stuff with isotopes. And I mean, you can do that. You can look at the half-life of isotopes, which is pretty fun. That's pretty convenient. You can see it's decay mode. I use that for stuff. In my senior physics lab, we worked with cobalt 40 or cobalt 30 something. And that was pretty fun to work with. And I had to do a lot of research on cobalt in order to, what's it called? Write a good report about it.
If you even just type in organic chemistry, you can get some cool examples there.
Oh, okay, that's cool.
Yeah, so this will give you a class of chemicals, but if you use it as a general topic there, then we've got some examples of things you can do with organic chemistry.
All the steroids.
Yeah.
Steroids. There you go. 15 steroids. Get
Yeah,
get swole with all these steroids. Don't do that. We're not
not that.
recommending that. But it's cool that you can look this stuff up. Obviously, for you, SL8, I got no idea if that's what you're looking for sure, but it's definitely there. It can be found, and obviously, the fact that these are members, that means these are most likely Wolfram entities. And that means that we can look up Wolfram entities and you can pull these information in computational format into your notebooks and you can work with. I will look it up. I hope this is what you're looking for, William. We have some stuff about proteins. I don't know what a proteomics are. I may have just butchered that, but you can look up properties like that, but you can also pull that into a notebook. And when you look something up like this, the molecular weight of insulin, you see insulin is a gray out box. This means that insulin is entity,
Right,
which
it's
we
its own
talked
input.
about last week.
Yeah.
We talked about entities, and these are all, and Wolfram Alpha uses entities. Oh, I see. Very cool, William. We can use these entities to, look up specific aspects and characteristics. And the nice thing is these are managed and kept up to date. So you don't have to necessarily worry about finding that information. You can pull things up like constants you need to know. So like, you can pull up all the constants you need, things like that. Mass of an electron, things like that. Constants where you're like, oh, I need that. Things like that.
Yeah, and that gets even more helpful when you're in a notebook and you type in like mass of an electron, and now you've got something that you can compute with too.
Muon interactions. I'm sorry. I didn't know you could look up interactions, particle interactions. It didn't work. Oh, well, that's a bummer.
Hmm.
Well, I don't even know what any of that is. But I hope it can be helpful. And obviously, if there's something you feel like that's missing out of the chemistry stuff, reach out, say, hey, I think this would be a good addition, because right now I think chemistry is a big focus. They're trying to expand some stuff. I know me, I'm not like that in the know on these things, but it's very exciting. I know lots of particle physics, and I'm pretty impressed with the particle physics stuff. We can see the decay modes. That's actually kind of cool. Yeah. I hope this was exciting.
Do you want to try, we talked about kind of a popular example, might be the limit from the movie Mean Girls.
Oh,
Um,
yeah. Is that, do I have that copied and pasted somewhere?
I can read it to you if you'd like.
Oh yeah, we can actually
You want
do
to try
that.
to do it in math input? So it's the limit,
Yes. Hold up. Limit as its x
x
approaches
approaches
0.
0. Yep. And the function is natural log of 1 minus x minus sine of x. And all that is over top of 1 minus cosine squared x, or cosine of
Oh,
x squared. Yeah, you probably have to type in like that.
it's
Yeah,
fine. It's good.
exactly.
It'll interpret correctly.
So this is, if you've ever seen the movie Mean Girls, there's a famous scene where the
It's
solution
at
to
the
this problem
end.
does not exist.
It's when
And
she
as we can see here, that
realizes
yeah, it's when she
she's a nerd.
character. We don't want
She
to
really,
spoil anything, but
I mean, for anyone that hasn't seen Mean Girls, you should go watch it. It's pretty
yeah.
good. Then you'll be on the know in October. What's it called? So yeah, you can look at things like that, and it's kind of interesting for even limits that don't, even when limits don't exist, it'll actually do the wherewithal to look at left and right limits. So that's kind of cool.
And I think it's really neat that it plots the solution for you too. So you can see
Mhm.
why the limit doesn't exist, because it has a different value on the left-hand, right-hand side.
Um, I'm sorry. I was just gonna look something up. I wonder if we can ask if
Maybe
I believe
just
this
put x squared in the
converges.
bottom.
No, I think this converges, but I just don't remember. I forgot.
Well,
Let's
wouldn't
see.
that just be 1? Yeah.
Yeah.
I don't try putting just x squared in the bottom, because that oh yeah, that'll work. Yeah.
Infinity. This should come to 0. But we can look at
Hmm.
step-by-step solution, and you can test some of your knowledge. For those of you that don't know, you can refer to L'Hopital's rule, and you can just know that since this power is higher than this one, that this will approach 0 before this does. So yeah.
Yeah, and if you don't remember that, we've got step by step, and it can kind of jog your memory on how you would get started on a problem like this.
I'm gonna misspell his name, but
No, that's actually right.
hopefully.
I mean, there's an accent on the O, I think, but you can't really enter that. So.
Oh, well, it's definitely not. Oh,
No,
well,
you got it.
L'Hopital is there. L'Hopital is there. He's just doing other stuff. Here we go.
Cool. And there's kind of the
Here we have the statement of definition. We know if it was proved or not. And we know
equation
there's,
itself.
yeah, so there you go.
That's proved by Bernoulli. I didn't even know that.
Well, there's like 3 Bernoullis. I don't know if you knew that. There's like 3 Bernoullis that all did stuff.
Of course. The
So
worst is there's like a billion Lorenzes. if you're wondering, if you see two things named after a Lorentz, it's a different guy.
We can look it up. We
There's
can
the
see all the.
Lorentz gauge, there's the Lorentz attractor, there's the Lorentz equations. They're all different, all three different people.
Yeah, so there we have we can look at. Well, I guess we just pull up the Lorenz unit. Oh well, something exciting. All right. Well, we're kind of getting to the end. The last thing I want to talk about is if you have Wolfram Desktop, you can. I'm going to stop sharing my screen. I'm going to open a notebook. I'm going to stop sharing a second, and I'm going to share my. There we go. I'm going to share my notebook. You can actually open. You can download a version of this for your notebook if you have Wolfram Alpha Pro. But if you have Wolfram Desktop, you can open a notebook that is a Wolfram Alpha notebook. So it'll be already ready for natural language input. So we could do, we're gonna look up
Do you want to
porcupine.
just show how you would open this? So if you're in
Oh
Wolfram
yeah.
Desktop or Mathematica, you can go to File, New, and it's right there under New,
Yeah.
Wolfram Alpha Notebook.
So
And then you would get a notebook just
I'm
like
gonna
this.
open, I'm gonna look up porcupine and we're gonna see if it'll search some stuff.
You want to just zoom in a little, Zach?
Oh yeah, I got it. Oh, there we go. We have
Thanks.
common porcupine. But the interesting thing is that this is a entity. So this, if I copy this and paste this, oh, it's gonna do that. This is an entity that I can use in like something for
Yeah.
like in programmatically. So I could like length of a porcupine.
Yeah, so this is going to default to kind of giving you shortest, most simplest answer that it can find. But you can also ask it for those full results that we were looking at before. So here it says, oh, the simplest answer for the length of a porcupine is, the answer, 23 to 37 inches. But if you wanted the full Wolfram Alpha results, you could also look for everything that we were getting online, which will, plot functions, do all sorts of things that you might not have even thought to do with the data.
Yeah, I guess we could do like, you could do, what do you want to do? We could just look up x squared. It'll probably plot it for us. And then we hit the full
Right,
Wolfram.
so exactly. It'll just give you x squared unless you ask for all of it, which is what we saw
this,
online.
yeah, and this is what we were talking about with the cells. So this is the same, this is what would pop up in your Wolfram Alpha. What's it called? Like if you're interested, you're like, whoa, look at all this stuff. Cool. And I'm like, okay, wait, I want this pod, I want it. So I want this, I want like, I don't know, actually, I want to take this pod as computable data, this x squared. So then I'm going, oh, I want x squared. It's going to grab that x squared out of it for me. So now it's x squared. So
Yeah, and so what's great about this too is you have a notebook now, and you can, as we would in a notebook, as you've seen us do in live stream, you can write text between these cells that sort of explains what you're doing. And you then might be able to even craft sort of a whole project out of just querying Wolfram Alpha, start off a project with a little paragraph about porcupines, say, let's find the length of a porcupine, ask Wolfram Alpha for the answer, and there you have it right in your notebook. So it's pretty neat for kind of creating projects with simple answers.
Mm-hmm. I think that's it. We kind of went over everything we wanted to go through. Feel free to use it, take advantage of it. Check with your University UF Pro, see if you can use that. Or if you're a professional, just see if this is going to be helpful for you, because it's helpful for me. And I'm doing like work and research. I'm not really in class as much anymore.
Yeah, no, it just
So
saves a lot of time sometimes.
it can be really helpful for information grabbing. Oh, wait, I think there's one last thing to talk about. I totally forgot about this. One last thing, and I think we should talk about this, is we can actually generate problems.
Oh, yeah.
This is like really important that we like talk about this, is for if you're practicing, say, calculus, as many calculus students are usually practicing, use substitution or integration by parts, which is something that comes up way more often than people give it credit. You can have randomly generated practice problems. Oh, am I not seen?
Oh, we can see your screen. Yeah, this is good.
Okay. Oh, I'm sorry. I will explain. So I went to the homepage and I went to the top right and I clicked apps. And under that app is problem generator. And then it takes you to a menu with a set of categories, of general categories. They're mainly mathematics based. They're the easiest to generate problems for. This
And
is
this is
from
being
the
expanded all the time.
homepage. Yeah, and this is from the homepage of Wolfram Alpha.
Yeah.
If you go to the homepage and you're like, okay, I'm here, I would like to practice. Oh, my page disappeared. There it is. So I'm here and I'm like, okay, well, I want to practice something. So I'm going to go to problem generator. And here we can create problems. For teachers, you can actually use these based on standards, based on Common Core standards. You can also make your own worksheets if you have to work with your students or you have to come up with something for them to work on. As an example, I'm going to go and practice calculus. I'm going to practice basic integrals. So I can find integrals and I can just type in the answer like it's 4, I'm going to guess, and it's going to go, no, that's not right. But it gives you a little hint. It says, try doing the problem.
And what's great about these too is they're actually being generated by the computer. They're not being, they're not questions that someone's written out and just has an answer somewhere. The computer comes up with these questions and knows the answer and asks you to figure out what the answer is. So it's great for practice. It's even great if you're a teacher and you want to assign your students, if you need some extra practice, go solve some integrals on Wolfram Alpha. Just a good way to make sure that you understand what's going on in your class. Okay, great. Was there anything else you wanted to show us with the problem generator, Zach? All right, I think we lost Zach, maybe some technical difficulties, but that's okay. We're pretty near the end of our time anyway, so I hope everyone learned something. For those of you going back to school, good luck. I'm sure you'll do great, especially now that you know of all these really nice tips from Wolfram Alpha. Maybe you've learned some of the Wolfram language from our other live streams. So with all those tools, I hope you just go back, have a great school year. Really just show everyone that you know what's going on now that you've got that problem generator, you've got Wolfram Alpha problem solving skills, and good luck.